All right, let's talk about something that on the surface sounds absolutely bonkers. Chaos engineering. I mean, the whole idea is to intentionally break your own stuff to make it stronger. That sounds like a total contradiction, doesn't it?
And that's the first question that pops into pretty much everyone's head, right? Why on earth would you pour all this time and energy and money into building some complex system just to turn around and try to break it on purpose? It just feels wrong. But trust me, there is some serious genius behind this madness.
Well, the answer is actually surprisingly simple when you think about it. It's basically a fire drill, but for your software. You don't wait for a real fire to find out if the alarms work or if everyone knows where the exits are. Of course not. You practice. You create this small, controlled disaster so that you're absolutely ready when, not if, the real thing happens.
So let's stick with that fire drill idea, but take it even one step deeper. You can also think of this whole thing as a vaccine for your app.
Think about how a vaccine works, right? We get a tiny, weakened version of a virus, and our bodies go, "Whoa, what's this?" And they learn how to fight it. They build up antibodies. Chaos engineering is exactly the same principle, just for software. We're injecting a small, controlled failure, maybe just a little bit of network lag, and we're teaching the system how to handle it. It's building up its own digital antibodies, its own immunity.
And that brings us to the more, official definition. But the key words here are really, really important. Notice it says this is a practice of running controlled experiments. The goal isn't to just create chaos for the sake of it. No way. The goal is to build confidence that your system can handle the messy, unpredictable real world. Because let's be honest, things are always going to break eventually.
So, okay, that's the what and the why. But how does this actually work? Because it's definitely not about just running around and yanking plugs out of the wall. This is a very scientific, very methodical process that's all about revealing weaknesses in a safe way.
First things first, before you even think about starting an experiment, you have to define its blast radius. It's a cool name, but it's really just about figuring out the potential impact. Are we going to affect just one server that nobody's using? Or maybe a tiny, tiny fraction of our users? The golden rule is you always start with the smallest blast radius you possibly can. This isn't about being reckless. It's all about being careful and prepared. And you can see how this whole thing is basically the scientific method in action. First, you figure out what your steady state is. What does normal and healthy actually look like for your system? Then you form a hypothesis, a guess. Something like, okay, if we slow the network down a bit, we think our app will just handle it gracefully. Then you do it. You inject that tiny failure, and you watch. You measure everything to see if your guess was right. If it wasn't, bam, you just found a hidden weakness that you can now fix. And then you do it all over again, making the system stronger each time.
Okay, so that's all the theory. But what does this look like out in the wild? For the apps and services that you and I use every single day. This is where it gets really cool.
So let's kick things off with something pretty much all of us do. Streaming video. You're watching Netflix, you're on YouTube. Well, chaos engineering is working behind the scenes 24/7 to make sure your movie night doesn't get interrupted. And this is the classic example. Netflix literally pioneered this whole field. They have this tool called Chaos Monkey that, during normal business hours, just randomly goes and shuts down their own servers. What could be a total disaster, a server failing, ends up being a complete non-event for you. Why? Because they've practiced for this exact failure thousands of times. The system just automatically and instantly switches to a backup, your movie keeps playing, and you are completely oblivious. Pretty amazing, right?
All right, next up, online shopping. Picture a massive site like Amazon, but on the busiest day of the year, like Black Friday or Prime Day. The stakes are just unbelievably high.
So, think about a product page. It's got the main product, sure, but it also has all these little extra pieces, like the customers also bought section. Now, what happens if that one little service crashes? Well, on a system that hasn't been tested, that one small failure could bring the entire page down with it. But on a resilient site, the one that's practiced for this, that little recommendations box just disappears. The most important part, being able to actually browse and buy stuff, is totally fine. The site handles the failure gracefully, instead of just falling over. And hey, for all you gamers out there, you better believe this is happening constantly behind the scenes in your favorite online games. An online game has a ton of moving parts, right? You've got the login system, matchmaking, your friends list. So what happens if the service that runs your friends list goes down? The absolute last thing a developer wants is for that one small problem to stop everyone from being able to play the game. So through these chaos experiments, They make sure that a failure in a non-essential part is completely isolated. Your friends list might look empty for a bit, but the most important thing, actually playing the game, still works perfectly.
So after all of these experiments, all these controlled failures, what's the big picture? What are we really aiming for here? It all boils down to one powerful word.
Resilience. It's the ability of a system to not just try and avoid failure. Because look, failure is going to happen, it's inevitable, but to be able to withstand it and bounce back super quickly when it does. And that boxer analogy is just perfect. It's not about being so good you never get hit. It's about being tough enough to take a punch, shake it off, and keep on fighting.
So what does success look like in this world? Well, in a perfect scenario, you, the user, notice absolutely nothing. Maybe on the inside, the engineering team sees a little blip on a dashboard for a second before the system just heals itself. The team learns something, makes a small improvement, and moves on. And the real payoff is that when a major, real-world outage does happen, it's just a little hiccup instead of a full-blown disaster.
If you're going to take one thing away from all this, let it be this. Chaos engineering is all about practicing for failure on your own terms, in a safe, controlled environment, so that your system can stay calm when the real world gets messy.
And that really leaves us with one last question to chew on. Whether we're talking about a massive website, a business, or even just a plan you've made for yourself, is it actually prepared for things to go wrong? Or is it just kind of hoping for the best? Because if there's one thing chaos engineering teaches us, it's that preparation, not hope, is always the winning strategy.